This is the Unit 16 practice quest. I'm going to quick go through this multiple choice section. It says a solution is tested and found to have a pH of 8.95. The solution is. In this one, should be hopefully a pretty simple question. It's a base because if it is less than 7, it is an acid. If it is more than 7, it is a base. All right, question number 2. This is just talking about the definition of an acid. An acid is a proton donor or an electron acceptor. Electron receiver here is the same thing, so it is D. Number 3, which of the following is not a property of an acid? So there are 6 properties of acids and 6 properties of bases. You need to familiarize yourself with those. This one, C here, is actually a property of a base. If you expose an acid to your skin, it stings and burns. If you expose a base to your skin, at first it will feel slippery. All right. Number 4, true or false? Acids, because of their corrosive powers, are more dangerous than bases. I showed you that video in class of that guy who drank the Drano and how he got all messed up from that, and that was a base. And so that was meant to show you that bases and acids are both really, really bad for you, so, be careful about both of them. So false, acids are not necessarily worse than bases. Number 5, solution A is measured to have a pH of 8, whereas solution B has a pH of 11. Solution A has blank hydrogen ions dissolved in it, as solution B. So on this one, what we're looking at here is how the pH scale works. This is a difference of 3. So each difference in 1 on the pH scale, we're talking about a factor of 10. And so if we've got a difference of 3, that's 10 times 10 times 10, which is 1,000. All right, and solution A, since it has a pH of 8, is going to be the more acidic solution, so it's going to have more of the hydronium. Number 6, what is the correct term for an acid with 3 hydrogens? This is triprotic. All right, so monoprotic is 1 hydrogen, diprotic is 2, triprotic is 3. Section B here, doing some problems here with the 6 equations that I'll give you. So you'll get those on the exam. Just make sure you're familiar with how to use them. Number 7, it gives you pH, and it's asking you for the concentration of OH minus. So you got to kind of think about a logical path. If we've got pH, I think it's pretty easy to find POH. So we take 14 POH is going to equal 14 minus 8.00, which is going to end up giving you 6.00. That 14 that we have for pH plus POH, we're going to consider that to be one of those like infinitely many sig figs sort of deal. So 6.00 is what we get here for the POH. And then to get the concentration of OH minus is going to equal 10 to the negative POH. Okay, plugging numbers in there, we get 10 to the negative 6th. All right, this needs to have 2 sig figs because the POH had 2 sig figs. That 6 on the front actually is just a placeholder, so we just count the 0.00. We count those zeros at the end. And so 2 sig figs, 10 to the negative 6th is D, 1.0 times 10 to the negative 6th. Number 8, it says you test a solution, you see the hydronium concentration is 0.00454. What is the POH? This one has a couple different paths that you can take. You can find the hydroxide calculation and then find POH, or you can find the pH and then go to the POH. I think the second option is better because I don't like that calculation between concentration of H plus and concentration of OH minus. I just think that people mess that up in the calculator a lot, so I'm going to go with the method where we convert this to pH and then we go to POH from there. So pH here is going to equal the negative log of 0.00454. Plug that in your calculator to 3 sig figs. You should get 2.343. Now POH is going to equal 14 minus that. And what we get is 11.657. Which is answer D. Something to note here, this had 3 sig figs originally. This one has 3 sig figs in the end because we're not counting that 11. So the pH rules for sig figs are kind of interesting and strange. We don't count anything before the decimal point. There's a reason for that, and it makes sense if you understand logarithms and exponents and how all that works. If any of you are ever curious about why that is, you can come in and talk to me and I'll let you know. All right, number 9 here. This one, it says we've got this hydronium concentration. It's asking for the hydroxide. So in this case, we're going to use that equation that relates those two, where we have concentration of H plus times the concentration of OH minus equal to 10 to the negative 14. All right, so in this case, what we'll do is we want to find the hydroxides. So we say concentration of OH minus then is going to equal 10 to the negative 14 over, what would they give us here, 2.05 times 10 to the negative 9, so 2.05. When you put that in your calculator, I would say E negative 9. You calculate that, you should get 4.88 times 10 to the negative 6th. All right, molar. If you look at the different options that we have available here, that is not one of them. So we're going to go with E, none of these. All right, onto the throwback. This one is on stoichiometry. What we're given in this problem is the number of atoms of sodium. We're asked for the number of liters of chlorine. So the first thing I recommend you do is write out your path. So we're going from atoms of sodium to moles of sodium to moles of chlorine to liters of chlorine. All right, the conversion factors there. Atoms to moles, 6.02 times 10 to the 23rd, Avogadro's number. Moles to moles, we're using the ratio. Moles to liters, 22.4 at STP. So going through here and then writing all of that out, we're going to start with 6.72 times 10 to the 24th atoms of Na. And then we know that there are 6.02 times 10 to the 23rd atoms of Na for every 1 mole of Na. And then looking at the balanced chemical equation, here we know that it's 2 moles of Na for every 1 mole of Cl2. And then with gas laws at STP, we know that for every 1 mole of Cl2, we have 22.4 liters of Cl2. Multiply all that through, you should get 125 liters of Cl2. You look at the options here. 125 is not one of them, so that means we're going to go with E, none of these. As always, if you have any questions over that, make sure you come in and ask. Do the review on this. Go back and look back on any worksheets for any of these topics that you're confused on. Look through the notes, and I think that this test should not be so bad.